started with, when we introduced this, we not only talked about the radicals, but we talked about the rational exponents. So let's look at some equations that have rational exponents and see how we need to solve those. So if we have this equation right here, 3b plus 1 raised to the 1/2 is equal to 7. Okay, there are two ways to look at this. First thing that you should think is the 1/2 power is the same thing as the square root. So this is really a problem that we've already done, but I'm trying to transition us into these problems. So let's look at it from the perspective of, well, how do I get rid of the 1/2 power? Well, since it's a power, we're going to raise both sides to another power. We want to get rid of the power. So we want that to be to the first power. So the reason why we square the square root is because they undo each other. Well, we're going to square this because when you raise a power to a power, you multiply. 1/2 times 2 is 1. So then you've just got 3b plus 1 on the left side. The power is gone. Okay? So, like I just said, the power is gone. So we've got 3b plus 1 on the left side, and 7 squared is 49. And then it's just a linear equation. Subtract 1 from both sides. 3b is equal to 48. Divide by 3, so b is equal to 16. Again, it's an equation. We should always check it. Plug in 16. 3 times 16 is 48. 48 plus 1 is 49. 49 to the 1/2 is the square root of 49, which is 7. Okay, so 16 checks out. And make sure that your b's and 6's don't look the same as mine kind of do right there. All right, let's look at example B. Okay, example B is a little bit different. It has the 1/2 power in it, but notice it is only on that single n variable. It's not around an entire expression. So we've got to get that n completely by itself before we can deal with that 1/2 power. So we're going to subtract 3 from both sides first. So we've got negative 21 is equal to negative 3 times n to the 1/2. Then we're going to divide by negative 3. So we get 7 is equal to n to the 1/2. Now we can finally raise both sides. We can square both sides. And we get 49 is equal to n. Just so that I can point out what you need to do if you use your calculator to check this. 3 minus 3 times 49. When you raise that to the 1/2 power, you have to put parentheses around the 1/2. If you do not put parentheses around the 1/2, it's only going to raise that to the first power, and it's going to divide the number by 2, which is not the same thing as raising it to the 1/2 power, because that's really the square root. Okay, and that does give us negative 18, so 49 is the correct answer. Okay, so when you put in fractional exponents, you must put parentheses around the fraction, or it's not going to work out. Okay, so that's pretty easy because that's what we've been doing so far. The 1/2 power is just the square root. What happens if we got something like the 4/5 power? Okay, that gets a little bit more interesting. So same principle still applies. We've got to isolate what is raised to the power first. So we have to divide both sides by 2 before we deal with that exponent. So we get 3x minus 58 to the 4/5 is equal to 16. So to get rid of this, we've got to raise it to the reciprocal power. So we raise both sides to the 5/4. We raise both sides to the 5/4 power. So now we've got 3x minus 58 is equal to, let's write that in radical form. Okay, let's write that in radical form. It's the 4th root of 16 raised to the 5th. It's the 4th root of 16 raised to the 5th. Now, this equation is actually going to end up with 2 solutions, and here is why. Because when we take even roots, we have two options. When you take the square root of something, it can be the plus or minus. The same thing happens with the fourth root. It's the plus or minus. So we're going to have two equations here. We've got 3x minus 58 is equal to the fourth root of 16 is 2. It's positive 2, but it could also be negative 2. So we need to set up two equations here. If you typed 16 to the 5/4 in your calculator, it would only give you the positive 2. You would lose your other solution to this equation. Okay, so that's why you have to know how to do this by hand. 2 to the 5th is 32. So when we add 58 to that, we get 90. Is that right? Yeah, 90. So x equals 30 is one of our solutions. For our other equation, that means the equation will be equal to negative 32. When you raise negative 2 to the 5th power, it's negative 32. So when we add 58 here, we get 26. Right? Negative 32 plus 58. Okay. 26. I was looking for a whole number when I divide, but guess what? It's not always nice and pretty. Okay, fractions are allowed. The real world's not all about whole numbers. Now, I would definitely check this equation. I would definitely plug this in and make sure that everything works out. Again, remembering that 4/5 power, you have to put it in parentheses. Okay, we get 32 when we plug in 30. And let's replace the 30 with 26 over 3. We also get 32. Okay, we also get 32. So two solutions here. So anytime you take an even root, you're most likely going to have two solutions. You should at least have two solutions initially. You may end up throwing one of them out, but you should get two solutions. Okay, let's look at another one like this. Okay, negative 27 is equal to negative 84 minus m to the 3/4. Okay, now that negative right there, we do not distribute it into our parentheses because that's multiplication. Multiplication comes after exponents. It has an exponent, so we can't just distribute that negative. Our only choice is to divide both sides by -1. So that makes it positive 27 is equal to 84 minus m to the 3/4. We raise both sides to the reciprocal power, so to the 4/3. Write it in a radical form. Cube root of 27 to the 4th. The cube root of 27 is 3. It's only 3. Okay, odd roots don't get the plus or minus because negative 3 cubed would be negative 27. Positive 3 cubed is the only thing that gives us positive 27. So we've got 3 to the 4th is equal to 84 minus m. 3 to the 4th is 81. So subtracting 84 gives us negative 3. Negative 3 is equal to negative m, so that means m is equal to positive 3. I should not have put it in a box yet because I got to check it and make sure. But usually there's not an issue. But you never know. It could surprise you. Okay, it gives us negative 27. Okay, we're good. Okay, makes sense? Pretty simple. It's like what we've been doing. The biggest thing you've got to remember, if you take an even root, you've got to consider the plus and the minus. Okay, if you take an even root, you must consider the positive and the negative. There should be two solutions. Odd root, you only got one choice, but if you take an even root, you got to have two solutions. Yeah, as long as if it's an even root, there's still two solutions.